In today's lesson, we will explore circle geometry, focusing on curves of segments, angles, and arcs. We will analyze various examples, key theorems, and applications. Let's start. For this question, the given information is OA the length is 26 centimeters and OM the length is 10 centimeters. Our goal is to find length of the curve. Here AB is the curve of this triangle. So we need to find this. For that, observe the point M. So this M is a midpoint of the curve, isn't it? Recall the midpoint of a curve theorem. The theorem states that the line segment joining the midpoint of the curve to the center of the circle is perpendicular to the curve. That means, according to the midpoint of the theorem, simply you can say AB is perpendicular to OM. That means OM is nothing but a radius. So AB is perpendicular to the radius, so which is nothing but at point M the angle is 90 degrees. So according to that theorem, we can say that this is a 90 degrees. 90 degrees is nothing but that is a right angle triangle. So if it is a right angle triangle, we can use the Pythagorean theorem here. So if this is the angle, so that means this is the theta. If this is the theta, the opposite side is OM. So which is nothing but 10 units. So this is opposite side. And our adjacent side is AM. Hypotenuse is 26. So now use in our Pythagorean theorem, which is opposite square, that is 10 square plus adjacent square, that is AM square, that is equal to hypotenuse square, that is 26 whole power 2. 26 whole power 2, which is nothing but 676, and 10 square is nothing but 100. AM square is 676 minus 100, which gives 576. If we take square root on both sides, then AM, the value is 24 units. This is 24 units. And our goal is to find the curve length, that is AB. Just recall the perpendicular bisector theorem. It states that a radius divides the curve into two equal parts. So OM is our radius. So OM divides the curve into two equal parts. So that is, we can say that AM, that is equal to MB. Now we need to find AB length, AB curve length. So according to this, we can write this as AM plus AM, so which gives 2AM, and we know AM length, which is 24 units. So we had write 2 times AM, which is 2 times 24, that is 48 units. So the curve length is 48 centimeters. Let's go for the another question. Given a circle intersected by two curves with arc length 22 degrees, this is 74 degrees. So this arc length is 22 and this arc length is 74. We need to find central angle. To find the angle of this X, just recall intercepted curve theorem. The theorem states that the measure of an angle formed by two curves that intersects at center, that is equal to half of the sum of the intercepted arcs. In simple words, we can say that to find the central angle, that central angle is equal to, you just simply add the two arc lengths, which is 74 plus 22. After that, you just do divide by 2. That's it. That's the theorem states. After adding these two, then you will get 96 divided by 2, that is equal to 48 degrees. Let's go for another one. Here given a circle, and the circle also intercepted by two curves. Arc length is 45 degrees and central angle is 80 degrees. We need to find arc length of this X. We need to find this arc length. Just now we recall the intercepted curve theorem, isn't it? The theorem states that the central angle, which is 80 degrees, that is equal to sum of the two arc divided by 2, isn't it? So just use the theorem here. We'll get 80 times 2, which gives 160. So that is equal to 45 degrees plus X. So X equal to 160 minus 45, which gives 115 degrees. That is your arc. Let's see one more example. We need to find this angle of A, B and C. Given information is this arc length is 60 degrees and here the arc length is 108 degrees. We need to find angles of A, B and C. First, we are going to find angle of A. For that, observe only the angle A. So if we have a circle and the diameter like this, and this is the angle A, and here the arc length is 108 degrees. This is the A, isn't it? This angle A is nothing but inscribed angle. So let's call the inscribed angle theorem. According to the inscribed angle theorem, simply we can say this inscribed angle is equal to half of the arc. So our arc is 108 degrees. So we can simply say 1 over 2 times 108, which gives 54 degrees. So the angle A is 54 degrees. Similarly, if you observe only B, so this is B, right? And this is your arc length, 60. According to the inscribed angle theorem, B equal to half of the arc. So that means the angle B is 30 degrees. So using the inscribed angle theorem, we found AB angles. Now we need to find angle C. First we will find this angle, because we know that in a triangle sum of the angles is 180 degrees. So that means just this angle is named it as D. So angle A plus angle B plus angle D. So sum of the angles is equal to 180 degrees. The angle A is 54 degrees, angle B is 30 degrees. Then angle D we don't know, just write as it is. Then that is equal to 180. So from here we can find out 180 minus 84, which gives 96 degrees. So that means angle D is 96. And observe here, angle D and angle C are vertical angles, isn't it? When two straight lines intersect with each other, the vertical lines are formed. From this we can say that angle D, that is equal to angle C. So if angle D is 96, we can say that angle C also 96 degrees. Like that, simply we can find using the theorems. Let's go for another one. The given information is, in a circle we have a tangent line. This angle is 60 degrees. This is 40 degrees. This is angle A. This is angle B. This is angle C. We need to find angles of a triangle inside a circle. So that means we need to find A, B and C angles. Let's see how to solve this. What we have? We have a tangent line. Let's take the tangent line. This tangent line, like a straight line. In a straight line we know that the angle is 180 degrees. Here the tangent line touches here, so it divides into like this. Here the angle is 60 degrees and here the angle is 40 degrees. We need to find angle A, isn't it? That means in a straight line the angle is 180 degrees. That means these three sum is equal to 180 degrees. 60 plus A plus 40, that is equal to 180 degrees. So the angle A equal to 180 minus 100, which gives 80 degrees, isn't it? So the angle A is 80 degrees. We are given a tangent and a chord. According to the tangent chord theorem, the angle between the tangent and the chord is equal to the opposite angle in the alternate segment. That means if you have an angle here alpha, so this is the tangent and this is the chord, that is equal to the opposite angle. So alpha, the opposite angle is here. So alternate segment, this is the alternate segment. So here this angle is alpha. For example, if this angle is beta, here also tangent and a chord, so that is equal to opposite angle. So this is the opposite angle in the alternate segment. In our given information we have this angle is 60 degrees, that is equal to, this is the opposite angle in the alternate segment. So according to that we can say that angle C is equal to 60 degrees. And also observe this side. So this is the 40 degrees and opposite side angle is this one. So that means angle B, that is equal to 40 degrees. Simply using the tangent chord theorem, we found this ABC angles. Let's go for the another one. In this question, given information is angle E is 33 degrees. At center angle is 76 degrees. Our goal is to find the sizes of the angles ACD. So we need to find angle A, angle C, and angle D. Let's start. Let's first focus on C. So this is the C, right? So let's take one circle and observe that C. So this is the BD line, which is nothing but diameter. This is the center, and this is the C. Now observe here. So this BD is nothing but arc. And so if BD is an arc and C is nothing but inscribed angle. So according to the inscribed angle theorem, we can say that the inscribed angle in a semicircle is a right angle triangle. Because in a semicircle, the length is 180 degrees. And we know that the inscribed angle is equal to half of the arc, isn't it? So that's why, so the inscribed angle is 90 degrees. Similarly, observe the A. This is the diameter and this is the inscribed angle. So angle A also, inscribed angle in a semicircle is a right angle triangle. Angle A also 90 degrees. So according to the inscribed angle theorem, we found angle A and angle C which are 90 degrees. So we are done with A and C. Now focus on D. For that you have to recall the inscribed angle theorem. So if you have a circle, if you draw an inscribed angle here, for this inscribed angle, the arc is this one, right? If you draw again one more inscribed angle here, for this also, the arc is same, isn't it? If you draw one more inscribed angle, that arc also same. So according to the inscribed angle theorem, so if these inscribed angles, the arc is same, that means these inscribed angles are equal. So that means if this angle is alpha, this angle also alpha, and this angle also alpha. For the inscribed angles, if the arc is same, those inscribed angles are equal. So now observe here, in our given question, observe AEB and ADB. This is AEB. So this is the inscribed angle and this is also inscribed angle. But the arc is same. So that means angle E equal to angle D, isn't it? So angle E equal to angle D. Because these two arc length are same, which is ABR. So from given information, we have angle E 33 degrees. That means that is equal to angle D. That means angle D also 33 degrees. So according to the inscribed angle theorem, we found angle D. And that's all for today. Catch you in the next video with more circle geometry fun.